Hello, in this video, we will be introducing the function blocks in Guide as well as the input messages that are transmitted over CAN. In this diagram, we can see how different sensors and steering input devices work with the machine to transmit data over the CAN bus. Here we can see the SASA, man-machine interface, MMI, wheel angle sensor, WAS, vehicle speed sensor, VSP, and GPS and aux inputs. The sensors needed for each vehicle depends on how the machine is configured. For example, different steering configurations, such as open loop joystick, closed loop joystick, GPS, and variable rate steering, will require different sensors. The vehicle speed and MMI will always be needed. The wheel angle sensor will be needed in closed loop joystick and GPS configurations. However, the WAS can be analog, in which case it would not appear on CAN. The SASA will be needed for variable rate steering, as well as for use with electronic disengage. The joystick will be necessary for use with the joystick steering modes. Joysticks can be analog for open loop. However, CAN joysticks are used the majority of the time. In the communication protocol document, we can take a closer look at the signals being transmitted by these sensors. The communication protocol can be found in the Downloads section of the PVED CLS page on the Danfoss website, in the firmware release package in the technical manuals folder. The communication protocol is used to break down the bytes of a CAN message. Each byte contains information that is sent over CAN and corresponds to a wire in Guide. Taking a closer look at the MMI messages, we can use this table to find and break down the bytes in an MMI CAN message. Using the CAN monitor in the service tool, we can find the CAN message with the identifier that matches that in the communication protocol. Each byte in the CAN message corresponds to a byte on the chart. For example, the first byte on the chart refers to the byte in the 0 position, and the second byte on the chart refers to the byte in the 1 position, and so on. The values in the message determine the selections for each signal. For example, the third byte on the chart is split into bits. Bits 8 through 7, 6 through 5, and 4 through 1. In the CAN message, this value is 8F. This must be converted from hexadecimal into binary for it to be read in the chart. 8F written in binary is 10001111. This number is then split up by bits, 10 for bits 8 through 7, 00 for bits 6 through 5, and all 1 for bits 4 through 1. This means that the MMI lockout GPS signal is transmitting that GPS2 steering is selected, and the MMI lockout aux is transmitting that aux steering is allowed. The bytes with a 0x in front of the value are already in hexadecimal, so they can be read directly from the CAN message. Function blocks can be used in Guide to format these CAN messages. For example, the MMI block contains the steering mode request, GPS mode, aux steering lockout, and aux mode request. This pre-made block is able to simplify the process of creating the CAN messages, as the CAN message is automatically formatted. To use a function blocking guide, for example, the MMI block, the block just needs to be selected from the function block library on the right side of the screen. The block can then be placed onto the screen, where the corresponding wires and buses can be connected. The parameter page for each block needs to be matched with the parameter settings in Service Tool. For example, the MMI block parameters are set to match the parameters in the SEHS protocol data page in Service Tool. However, the PGN offset will only be shown in Service Tool when proprietary B message format is used. Different function blocks can be added for use with different functions. For example, if an aux device, such as a joystick, was being added to the machine, then a new page would be created. In this page, the function blocks for the joystick can be added. The function blocks must have a primary and a redundant block. These blocks must be named differently, or there'll be an error in the code when compiling. This is an example of a programming guide that is not using function blocks. This shows what is replaced by the function blocks, and how function blocks simplify the CRC and sequence counter parts of the code. If we look back at the communication protocol for the MMI block, we can see that bytes 6 through 8 contain the CRC and sequence counter information. Multi-axis will use a different function block library than the standard firmware, as the multi-axis blocks will have different functions. For example, the multi-axis MMI block on the left is sending different information, such as in-axis position and angle, rather than the traditional MMI block on the right, which is sending information such as GPS mode and steering mode request. That is all for this video. Thank you for watching.